Good afternoon. I am Suhas Nandurdekar, Vice President ISCC. On behalf of Managing Committee and Governing Body members, welcome you all for the webinar on surface sanitization. Nowadays, sanitization has become an essential program in our lifestyle. Before we proceed for the webinar, I would like to inform you that ISCC jointly collaboration with EcoCert going to organize online training program on organic and natural cosmetics and Cosmos certification, about which Ms. Rosen, EcoCert business developer, training and consultancy, will give you brief information. Over to Rosen.
Thank you, Suhas, and thank you everyone for joining today's webinar. I will just quickly share my screen. As Suhas was saying, we're very happy and thrilled about this collaboration between EcoCert and ISCC. So just very briefly, EcoCert Group is a certification body for natural and organic cosmetic. And we are also one of the founding members of what you might have heard before as a cosmetic professional, Cosmos, which is one of the leading certification scheme for organic and natural cosmetics. Just to give you a few numbers on what is Cosmos and why is it important and why we're even doing this collaboration on Cosmos, is that this certification, because of a lack of national regulations on organic and natural cosmetics, this certification called Cosmos brings trust and guarantees to the product. So today, EcoCert is certifying more than 20,000 products across the globe, and India is one of the growing markets for such products as well. So now talking about Cosmos specifically, you can either be Cosmos Natural or Cosmos Organic certified. And it is a very important trend as per the market demands and the consumer expectations to have such certifications. Talking about our joint training session, EcoCert, we at EcoCert are very happy to have this collaboration with ISCC. The idea is really to give you all the tools on understanding Cosmos, what is this certification all about, and for ISCC to give you more insight on natural cosmetics. So the idea is that we would have qualified trainers from EcoCert and from ISCC to carry out an interactive session with concrete examples and with case studies to answer all your questions on natural organic cosmetics and on Cosmos. To go through very quickly on what would be the agenda of this online training coming up probably in August, we will be covering what is the Cosmos standard, its requirements as per the formula, ingredients, packaging, and labeling, the certification process, and a bit more about natural cosmetics that would be covered by ISCC. So the whole point is that it is going to be beneficial for you as an ISCC member to join this collaboration and this training. Why would you have to join this training if you're starting your business, if you're going and aiming already as to certify your product, if you're a formulator, if you're into R&D, or really any professional in the cosmetic sectors? Now I think we can all agree that organic and natural cosmetics are something growing that people are concerned about, asking question, information, and we thought with ISCC team that it would be relevant to have this collaboration and to organize this training. So we were very happy to organize such trainings together, and we had great feedbacks from participants before that it was very useful for them at any stage of their product. If they are just professionals in the cosmetic sector, not really aiming at getting the product certification, but getting to know more about it. And so this is what is coming up on our collaboration with ISCC and EcoCert, and I'm sure that Shalendra and everyone from ISCC will let you know more about this training, upcoming training, and we'll look forward to having you there. So that was just to let you know a bit more about this upcoming training and our collaboration that I'm very excited about. So I'll pass it on over to you, Suhas or Shalendra, to introduce Dr. Sunil today.
I would now request Mr. Mahesh Chavan, who is our managing committee member, to introduce our eminent speaker, Professor Bhagwat. Over to Mahesh. Mahesh.
Thank you very much for giving me the opportunity to introduce a very nominated person, Professor Sunil Bhagwat sir. Dr. Sunil Bhagwat is a professor of chemical engineering and a dean of academic programs at the Institute of Chemical Technology, that is UDCT or UICT. He is a former head of the Department of the Chemical Engineering. His area of specialization is interfacial science and engineering, artificial neural network, energy engineer and exergy engineering. His group, which is the over of 35 doctoral students completed and 80 masters, has successfully completed several research projects funded by the government agencies and the private companies in India and even in abroad. His group won the NOSIL Award for Indian Institute of Chemical Engineering in 2012 and the Bri Air Asia Award for HVAC in 2013. He was awarded Best Teacher Award in ICT several times and also Indian National Science Academy Teacher Award in 2016. In 2019, the UDCT Alumni Association's Distinguished Alumnus Award, that is for academic category, was bestowed upon him. He is also an active consultant to the many chemical industries. He won over 35 international publications and over 80 national and international conferences presentations and 10 patents on his credit. Over to Professor Bhagwat sir.
Yeah, thank you, Mr. Sawan, for that nice introduction. I'll begin with my presentation straight away. Today, I'm going to talk about hard surface sanitization, especially surfactants and active chlorine. I hope my presentation is on full screen, if somebody can confirm.
Yes, sir.
Yeah, thank you. And in fact, talking about sanitization, microbes is not really my usual area, but I came in contact with this area naturally as everybody else came in the last couple of years because of COVID-19. Let me begin with first telling you where I come from. I come from this Institute of Chemical Technology, and just one slide explaining who we are. We are an institute established in 1933. We have 9 branches of undergraduate degrees. Along with that, we graduate more than 100 doctorates every year. So which means we publish a lot, and we are also very closely connected with the chemical industry in India. A very large number of our graduates end up becoming entrepreneurs, and there are many Padma awardees amongst our alumni and faculty as well. And the Confederate of Indian Industries, the ICT award for the best industry-related institute in the chemical zone naturally came to us. So these are the shoulders I get to stand on. With this, let me now begin with the main subject of my talk today. When we talk about the world of microbes, which is a word quite general, I am going to talk to all of you. Some of you may feel this is too simple and pedagogical, but some of us probably like me are new to the subject, and therefore it will help to give some background on this as well. Mainly three types of microbes that we are worried about. One are called bacteria. These are unicellular organisms. Their shapes can be different. When they are rod shaped, we call them bacilli. When they are spherical shaped, we call it coccus. Spirili are the spiral shaped ones, and vibrio are the curved shaped ones. So depending on their shape, they are given different names. These are prokaryotic cells. That means they do not have a nucleus. The second type of microbes that we normally worry about are fungi. These are mostly multicellular. They are eukaryotic. They have a nucleus. And the third kind, which has got us all worried in the recent times, is viruses. And that means these are non-cellular entities. These are not really organisms which are cells. They consist of a nucleic acid core and they have a protein coat, but they are not really living organisms. They infest prokaryotic and eukaryotic cells, and that causes disease, including, of course, the current COVID-19. The structure of a bacterium is usually studied by a stain, which is called the Gram stain. This Gram stain, then you say something is Gram positive versus Gram negative. Now, when the Gram stains, the Gram stain stains that particular cell, it then means that this structure has a thick peptidoglycan cell wall. This cell wall on the inside has a plasma membrane and on the outside has a capsule. And these are the kind of microbes, the bacteria which are Gram positive, which are easily treatable or relatively easily treatable using antibiotics. The other type are Gram negative bacteria, and they have very thin peptidoglycan cell wall, and they have one inner plasma membrane, one outer plasma membrane. Now, these two types form the bacteria that we are worried about. But what we really need to know about when we say sanitization, it is the pathogens. And pathogens means those microbes which are pathogenic, and those are not limited to bacteria. The Gram staining bacteria, they do not have an outer lipid layer, and they can be targeted by antibiotics. The Gram negative, on the other hand, they are harder to kill. But bacteria is not the only type which is pathogenic. The ones which we are today worried about are viruses. In fact, many pathogens such as the HIV, the hepatitis B, and hepatitis C, of course, Ebola virus, the coronaviruses, Zika viruses, there are plenty of them, including, of course, the current SARS-CoV-2. These, most of them, or rather a large many of them, they are enveloped by a lipid membrane. As the diagram shows, there is this RNA and protein around that RNA, and then there is a lipid bilayer as if it was a cell wall, but mind you, it is not a cell wall. It is a lipid bilayer which is covering it, and then the coronavirus has this corona-like glycoprotein spikes, which is what gives the name coronavirus to that. And one of those coronaviruses, there are plenty of them, including common cold virus really, but the one which we are worried about today is called SARS-CoV-2. And that is the one I will be describing more when we talk about sanitization. These microbes usually can be treated or attacked by application of heat, by application of cold. At least they can be stopped from growing by application of cold, by desiccation, that means completely by drying, by osmotic pressure difference, because of which they would then dry out in such a way that they would not be effective. we can filter them out. There are multiple types of radiations, including ionizing radiations, ultraviolet radiations, which can be used to attack these, and of course, chemical agents. None of these, almost none of these, are effective in treating a disease. That means if the virus has already entered a body, these methods are not the ones which we use to treat. Those are strictly in the domain of a medical science. However, what we will be looking at is preventing the disease by preventing contamination. And that means we will be talking about chemical agents, which include materials like alcohols, aldehydes, halogens, heavy metals, organic acids, oxidizing agents, some phenolic compounds, some quaternary ammonium compounds, and surface active agents or surfactants. Now, amongst these, as you can probably see, most of these are not something you can use inside the body, barring, of course, some famous wrongly quoted statements of big people, but you cannot digest any of these and treat your body with these, but you can treat a surface. And now amongst the surfaces also, the surfaces I am going to talk about are hard surfaces. That means typically a doorknob, a table, a chair, and things of that kind, and not skin surfaces, about which probably as Society of Cosmetic Chemists, you definitely know much more than what I can tell you. So my talk is more about the hard surface sanitization. Now, amongst these chemical agents, alcohols disrupt lipid bilayer and they denature the proteins. Alcohols also evaporate and go away into air after application. These are distinguishing features. When we look at other agents, these features may not be there. Second type is oxidizing agents. And oxidizing agents mainly of two kinds which are important here. One is hydrogen peroxide. And hydrogen peroxide usually then oxidizes cellular components. That's how it will tackle the microbes. Second type is active chlorine. And these are the ones which are more talked about. And this is where we need to be a little more careful. And I'll have some description of this later again, of course. Mainly hypochlorite type. These are strong oxidizing agents, no doubt. But hypochlorous acid form of this material is the one which is more active of the two. And I'll mention more about this shortly from now. Surfactants are also used for this purpose. And these are typically not really what we call germicidal. In fact, historically, Louis Pasteur has made this knowledge famous that if you wash your hands before you eat, you are safe. And in that sense, yes, surfactants do kill a lot of microbes, but at much higher concentrations. We'll be describing that as well. But they mainly work by removing or degerming the surface rather than actively killing the microbe. The next category is quartz or the quaternary ammonium compounds. These are a big hammer in the sense they kill almost everything. There are very few exceptions what does not get killed by these quaternary ammonium compounds. And then there are aldehydes, which are very potent, of course, especially glutaraldehyde is particularly very potent, as we will see some of the data. Quaternary ammonium compounds, in fact, can be used on skin as well. They are considered safe on skin. In fact, one of the very popular disinfectants for wounds is based on a quaternary ammonium compound, cetyltrimethyl ammonium bromide or cetrimide, but not many others. Surfactants, of course, we use on the skin, but not many other compounds can be used on the skin. And when we, just a minute, I'm giving a lecture, public lecture, it's written here. May I continue with my lecture? I'm so sorry. I was talking about surfactants and then aldehydes. These chemical agents, they form the main agents for surface sanitization. Now, why do we do sanitization and what are the considerations that are important for sanitization? First of all, let us see the mode in which the infection can get transferred. One is that the infected person exhales something in the air and that is inhaled by a healthy person. The infected person, if he is not close by, this mode will not happen. And the prevention for this, we are fairly well aware, using masks is very important for this. The second kind is the infected person shakes hands or comes in skin contact with a healthy person and that transmits. Then you have to worry about skin sanitization. But the third type is that the infected person exhales or coughs onto a hard surface or touches that hard surface which gets contaminated. And this is the one mode where without even realizing that you are actually coming in contact with that infection, you would be touching that surface as a healthy person after the first contact, and this indirect contact with contaminated surface will then lead to a healthy person getting infected. When we talk about this kind of transfer of infection, we talk about its removal through logarithmic reduction. We also talk about minimum inhibition concentration and a zone of inhibition for growth of bacteria. We also have to worry about the damage it will cause to the substrate. Skin, of course, we are always very careful about, but even many hard surfaces do get damaged by some of these sanitizing agents, depending on whether they are porous, non-porous, and so on. We have to also worry about the environmental toxicity of the sanitizing agents that we use. The mode of applications typically for surface sanitization is either a spray or a wipe or actually dipping the surface into a liquid. So we are going to look at all these three methods where materials will be useful. However, one very important consideration is that while trying to sanitize the surface and making it safe, we do not want to cause another problem. And this is where I'm talking about one of the most effective agents in sanitization, and that is quaternary ammonium compounds. If not used at the right concentration and exposure is continuous and at very high concentrations, it can cause a lot of damage like inflammatory cell infiltration, nerve degeneration, neutrophil function getting inhibited, dermatitis and irritation, and so on. And oxidizing agents, when we use, these can attack metals and corrode, and this becomes a long-term damage. That is, for example, a doorknob, if I am treating with a sanitizer, thinking that it is doing me something good, and in a short while, I have corroded that, then I'm exposing myself to another danger. So these aspects become very important. And this is one example I'm showing how surface active agents, which are not necessarily quaternary ammonium agents, how do they work on gram-negative bacteria as well as on enveloped virus of the kind SARS-CoV-2. Surfactants and lipids together actually form the membrane of bacteria as well as viruses. Meaning, when we use surfactants to attack that, we are using what is forming that protection layer of the virus or the bacterium itself. So these can participate in that lipid layer of the virus, and they have a crowbar effect, as this diagram shows, that this agent which is entering here, replacing this lipid membrane, opens out this RNA, and therefore it becomes inactivated by that. Now this action of course requires the higher concentration formulations, like we use soap or liquid soap for hand wash and so on. These are the earliest types of materials, and they are still considered the safest. Next, and very effective at small concentrations, is this hypochlorous acid and hypochlorite. These include usually the salts like sodium hypochlorite or calcium hypochlorite. They can ionize when present in aqueous solutions. NaOCl will ionize into Na plus and OCl minus. HOCl can ionize into H plus and OCl minus. And what is key here is the presence of hydrogen ion. It pushes this equilibrium to the left side. That means towards HOCl instead of H plus and OCl minus. And this is decided on the basis of the Ka value, that is the value which is of dissociation of the HOCl, giving H plus and OCl minus or Na plus and OCl minus. The pKa value is 7.52 for this hypochlorous acid. So the Ka value is 10 raised to minus 7.52. And at pH at 7.5, in simple word, it means that half of the total hypochlorite is in the free acid HOCl form, and half of it is in OCl minus form. And HOCl is a far more effective oxidizing agent than the OCl minus ion. So therefore, one would think that we should have the material in HOCl form. However, there is another side to the story, which is stability. And the stability is such that at pH which is low, where the fraction is more in HOCl form, as you can see at 7.5, it is halfway. Lower the pH, more the HOCl content, higher is the oxidizing ability and antimicrobial activity. However, when you look at the stability, it is exactly opposite. The storage stability of HOCl, as you can see, is in days. So if I look at the storage days versus logarithm of C by C naught, as you can see, -1, which means it has already got to 1/3 by the time it is 15 days. And this means I cannot make a product and keep it on shelf at all, because 15 days shelf life is not of any use. And here is where the key of using this material is, that if I make a formulation which is of low pH, which is very effective, it cannot last. And if I make a formulation of pH like 8, 8.5, which will last longer, have a good shelf life, will be quite ineffective in oxidizing what we want. And the key here is that as stored, the material has to be at a higher pH, and when used, it should be at a lower pH. And for this, there are many tricks, including dilution, which are used, dilution just prior to use, but that is very, very important feature. Otherwise, our HOCl based product will be completely inactive by the time we actually spray or use it. Or it will be something which is in hypochlorite ion form, which means that it is not going to be antimicrobial at all. So this factor is very important for that active chlorine, and having active chlorine in hypochlorite form during storage and in HOCl form during usage is the key to its usage. Now let us see how long do viruses last on various surfaces. Viruses on stainless steel, here data on the SARS-CoV-2 is very limited. So these are some of the viruses which are used for comparison. These are all coronaviruses of different kind. First one, say for example, here is the MERS, the Middle East respiratory syndrome virus. It is also a coronavirus. As you can see, if the inoculum, it is a typical inoculum 10 raised to 3 to 10 raised to 7 viral titer. At 20 degrees Celsius, it will last for 48 hours. That means if somebody has touched stainless steel surface at room temperature till 48 hours, the virus is going to be viable. It can transmit itself to another person. And if you want to make it inactive, then you have to do something. The word is not kill the virus, because virus is not a live being. We don't say kill, but it has to be made ineffective. All these other viruses, you can see they last much longer, up to 28 days. On aluminium, metal, the lasting is even more. The most common surfaces like metal, wood, paper, plastic, you can see it is several days, 4 days, 6 days, 9 days typically. And on other plastics like PVC, silicone, also 4 to 5 days. So typically many people, when they receive material, they keep it aside for at least a week and then they will handle it. Typically that is probably a good thing to do if you are not able to sanitize that particular material. Disposable gowns, ceramic, Teflon, all of them, several days the virus is going to last. These are all research references with which I have made this table. Some other results also for different types of surfaces. They have used specifically what are permitted to be SARS-CoV-2 surrogates, human coronavirus and SARS coronavirus. SARS is that respiratory syndrome only, but not the current COVID causing SARS-CoV-2. So these are SARS-CoV-2 surrogates, and you can see the viral titers, when we keep them there, it is easily up to 5 days that the virus is going to last. And that is why we need to sanitize the surface before it can be touched by a safer, by another person. However, there are some surfaces which by itself are very good. As you can see, half-life on cuprous oxide is very small. Time for decay is just 1 hour. And this is actually used in making a product, as we will see later. And all the studies indicate that half-life is in days or several hours. It depends on humidity, it depends on temperature. However, we must make sure that it is sanitized before we touch. So what are the biocides that we will be using for sanitization? Here is first of all the suspension test. In the suspension test, you will dip the material or the surface and then see after a certain amount of exposure, how much is the reduction in the viral content on the viral titer. Ethanol, which we use for hand sanitization, 95% in 30 seconds, the log reduction you can see is 5.5. So 10 raised to 5-fold reduction in just 30 seconds if I use 95% ethanol. If I use 78% ethanol, it is still more than 10 raised to 5 reduction in 30 seconds. However, moment the concentration comes down to 70 or below, it is likely that it will require 10 minutes before it becomes 10 raised to 4-fold reduction. Isopropanol, which is also used, in fact, more commonly used in hand sanitization materials, can also be used for surface sanitization. And at 70-75% in 30 seconds, there will be 10 raised to 3-fold or more reduction that we get in the viral infectivity. 10 raised to 3-fold is typically the key number that we look at saying that it has become ineffective or inactive. Then comes this quaternary ammonium, benzalkonium chloride. Now the first result is very confusing. As you can see at 0.2%, this solitary result showed no virus reduction activity. I think this was because that particular measurement did not work. Otherwise, there would have been some reduction, some increase, some number there. But that 0 actually means that the result was for some reason lost. 0.05%, as you can see, in 10 minutes, it is 10 raised to 3-fold with different kind of strains which have been tested. However, when you talk about very low concentration like 0.002, it is 3 days which is giving 10 raised to 3. So which means it becomes ineffective by the time you talk about 0.002% concentration. Didecyl dimethyl, Again, at 0.002%, 3 days, 10 raised to 4 fold. That means it is too low a concentration. Digluconate, chlorhexidine digluconate, it's considered a very strong active. And at 0.02% concentration also, in 10 minutes, it reduces, but only about 5 to 10 fold. Now, these can be used for all these agents, then therefore can be used for surface sanitization. As you can see, hypochlorite at the right pH, 0.2%, 30 seconds, it gives more than 10 raised to 4 reduction. At 0.01%, you require about 10 minutes. And then also if the reduction is not 10 raised to 3 fold, but maybe 100 fold or 10 fold reduction. And so 0.001% also you can see is 0.9, that means almost 8 to 10 fold reduction. Peroxide 0.5% in 1 minute gives 10 raised to 4 fold reduction. Aldehydes, I had said, were very effective. As you can see, even at 0.7%, 2 minutes, 10 minutes, you get more than 10 raised to 3 fold reduction. Povidone iodine, it's an active. And as you can see, at even low concentrations, within 15 seconds, we are able to get 10 raised to 4 fold reduction. So this is a very effective antimicrobial specifically for coronavirus. Now here, these are tests on the surface. So earlier was dipping. This is not dip method, but a volume which has been sprayed onto a surface. You can see alcohol, ethanol at close to 70%. Within a minute's exposure time, more than 10 raised to 3 fold. At something higher than that, it would have been more effective. Benzalkonium chloride at 0.4%, little less than 10 raised to 3 fold in 1 minute. Hypochlorite at 0.1% also, you can see within a minute more than 10 raised to 3. Whereas when you come down to 0.0406, it is much less effective, just about 2 or 3 fold within a minute. Aldehydes, as you can see, are very effective. Peroxide vapors have also been tried, but it requires few hours before they will reduce it to 10 raised to 4, 10 raised to 5. But these have been tried because vapors of peroxide would exist in regions, and then therefore for several hours also they can exist. UV light is another very effective way of sanitizing the surface. Pulse xenon UV light onto hard surfaces. You can see on slide surface, this is a glass slide surface. Exposure time 1 minute, 2 minute, 5 minutes. You can see that 0 minute, of course, no reduction, but 1 minute 99.97. That means this becomes a log reduction of more than 3.5. 2 minutes 99.997. So 4.5, 10 raised to 4.5 reduction, and it is 5 minutes, even more reduction. So beyond 2 minutes, it's not changing much. Or here they have done this experiment with trying to reuse an N95 respirator valve, the respirator mask. And you can see that at 0 minutes, it had a very high viral load there, no reduction. But with 5 minute exposure, the 99.998 virus became ineffective, 10 raised to 4.79 fold reduction. So all these methods are viable methods for these sanitizing the surface, making them virus free. There are some treatments for the surface, permanent treatment. Now, these are not treatments like sprays, but these are permanent treatments which are recently becoming available. For example, a metal surface, which was normally only, let's say, a brass knob or a steel knob, we can make it Cu2O, put in PU coating. These specialized coatings have been developed. That polyurethane makes it the coat, but it contains this cuprous oxide. And there is a 10 raised to 3, 10 raised to 4 fold reduction, that as you can see, log reduction greater than 3, 99.9 plus. And on various surfaces, glass, steel, when you put these coatings, you get this kind of a reduction. These are promising materials. You can see that these are fairly recent research output. They are probably not yet out as products, but should be very soon. So looking at all these sanitization methods that I talked about, we have to look at key questions like, is it having efficacy? Does it have emerging viral pathogen claim. That means basically SARS-CoV-2 effectiveness. The wet contact time required to kill SARS-CoV-2, kill means make it ineffective, I would say. Whether it is effective in 10 seconds, 30 seconds, 5 minutes or 2 hours, that makes a big difference. There are certain things which you can spray and keep for few hours, certain things which you need to immediately make them safe in seconds. Then the safety profile. If the pH is acidic, you don't want skin to touch it. And then there can be potential toxicity or irritation to a person, but toxicity to environment, which is also very important. There are some materials, especially quaternium, with at higher concentrations, if they go into aquatic bodies, they can cause a lot of irreversible damage. But we have to always think in terms of an immediate advantage versus some long-term damage and the right concentrations so that the long-term damage is not anything to worry about. Then the practicality, the method of delivery. Some things are possible to be made used as pre-moistened wipes. Some of them require a concentrate which needs to be diluted, especially the hypochlorite type. They would be in the hypochlorite form pre-dilution, will become hypochlorous acid post-dilution and need to be used within a matter of few hours. Can it be delivered through different ways like sprays and so on? And what is it compatible with in terms of surfaces? For example, there are woods which will get damaged, wood coats which are there on many materials. For example, they would get damaged by oxidizing sprays and the discoloration will be permanent. Metals also, if I put anything oxidizing, especially containing active chlorine, the metals would corrode very fast. It will not show within days, but within months, the surfaces will get corroded. So that's about practicality of the use of that. And of course, the last, but the most important industrially is the availability and cost. Is it currently commercially available? Is it a viable purchase? Is it a proprietary material? Is it economical for the particular usage? So given all these considerations, now we can make our formulations with this knowledge about surface sanitization for different applications. I had only this much to say. Thank you for your patient listening, and I'm open to any questions that you may have.
Hello. Hello.
Yeah, hello.
Yeah, no, I just request the participants that if they have any questions, maybe they can post them in the chat box so that we can take the questions one by one.
Be watching the chat box or maybe one of the
I'll give you the questions, Doctor. I request the participants to post their questions in the chat box. I hope everyone has heard it. There's one question. What is the recommended level for quaternary ammonium compound, from quartz specifically?
Recommended concentration for?
Quartz.
What? Quaternary ammonium compounds?
Yeah.
For sprays on things where we would be touching by hand, the recommended concentration is around 0.1%.
And are there any standard test protocols to be followed for this?
Yes, in some of these publications, the test protocols are given, but having access to SARS-CoV-2, there are very, very few labs which have that. So these experimentations are done on what are considered surrogate viruses. So there are standard SGS and there are many companies which do that kind of testing.
There's another question. If we use antimicrobial agents in the products and the product comes in contact with the packaging caps, will it cause corrosion of the caps?
Metallic caps. If
Yeah,
it is an
metallic caps.
oxidizing type, especially if it is with active chlorine, it can, and therefore there are PP caps that are underneath the metal cap. So with that, then there shouldn't be a problem.
There's another interesting question. Which is the most safest ingredient to be used for the surface sanitization?
The safest, there would be two types. One is UV light, so it doesn't leave behind any residue. And second is hydrogen peroxide, so that it leaves behind only water as a residue after oxidization. However, in hydrogen peroxide, one of the biggest worries that you would always have is that because hydrogen peroxide is an organic manufacture, it involves intermediate materials which are aromatic compounds, aromatic organic compounds, and catalysts which are heavy metals. So any residue of either of these in that hydrogen peroxide makes it bad. So with strict control on the ppb levels of heavy metals there and ppm levels of organic contaminants present in the peroxide is essential.
While doing sanitization, is there a common method to ensure that the surface has been completely sanitized? How can we ensure it?
At household level, we cannot measure it. We have to rely on some other lab results on similar materials. Typically, bodies like ISCC would look into that before somebody can advertise saying that this is the material, or even if somebody advertises, immediately counter person is going to make a complaint and ISCC will look at that advertisement and verify their actual technical data. So it's not something you can test by looking at it and say that is there, at least so far for SARS-CoV-2, there is no spray which I will put and check whether the virus is there. Nothing as simple as that.
What is the retention time for quartz on fabrics or garments?
Okay, garments is a different story. Garments will actually suck the material inside. They would go inside and adsorb. Typically, quaternary ammonium compounds are used in garments for what we call that softening agent. Post washing by detergent, you use softening agent. These are quaternary ammonia, and they would typically stay for a few days, and they would get lost only in the next wash.
Yeah, normally, I think even for conditioning, we use fabric softeners generally.
Yes. These are typically dialkyl dimethyl kind of materials which are used for.
Is there any long-lasting or retentive antimicrobial or antiviral agent?
The last thing which I mentioned was that PU coating with cuprous oxide. Those are like semi-permanent coatings. They would last for a year also. Without, I mean, a few years probably they would last once coated. Otherwise, it is essential that every time you suspect that it has been exposed to contamination, you will have to put that spray or wipe once again.
So with these enveloped viruses, can they be killed with quartz only, or you'll have to use other agents like alcohol and all?
No, they can be made ineffective by quartz. At around 0.1% concentration, benzalkonium chloride very effectively can make it ineffective, make the virus ineffective. Except that one result which was at 0.2%, which could not. There are other results that 0.05 to 0.1%, fairly effectively it is making it, making the virus ineffective. And at that concentration, it is considered safe on skin as well. In fact, many of the cosmetic products also probably use it as an antimicrobial.
Yeah, where we do. Yeah, unlike your hand sanitizers and all, is there any national test standard for surface sanitization or surface sanitizers?
I have not seen any test in the our standards kind of a thing. But if you look at FDA,
okay,
they have on their website several materials which they have passed. In fact, they look at US FDA particularly, not just material. They would look at the specific product and they will put the test results on their site.
But is there anything under study or development of that sort here in India? Any idea?
Not that I am aware of. No, I don't know.
Cuprous oxide or PU is in which form specifically?
solid particles, probably nanoparticles, embedded inside the PU. Polyurethane. PU is polyurethane.
Any more questions? Maybe if anybody has any specific thing, maybe they can write to us as well. Maybe we can pass it to doctor for any more details. And anyway, we are running short of time now. So I request our treasurer, Dr. Naber, to come over and extend his thanks to the participants and the speaker. Over to Dr. Naber.
Yeah, thank you, Shailendra. I think Professor Sunil Bhagwat has set the tone, and sanitization is going to be here for a long time, even if we don't want it also, because such is the situation. And I'm sure COVID has taught us a lot of things. And even though it has made our life little tough and miserable, but it has also given us a lot of lessons to our great advantage. I think Professor Sunil Bhagwat, who is a veteran, though he is too modest to say that he is not known to this field, but knowing him since the college days, he has done a lot of pioneering research on basically surface activity. And what he talked about sanitization was a flavor of that only. He has explained to us in very details how the sanitization has to be done, what are the advantages, what are the precautions one has to take, what are the disadvantages. And I think surely our learned audience will take a lot of advantage of these pointers, what he has raised. And thank you very much, Professor Sunil Bhagwat, for a very nice presentation. I would also like to thank Mademoiselle Rosaline of EcoCert for giving us a brief outline of the things to come in the context of close collaboration between EcoCert and Indian Society of Cosmetic Chemists. I think a lot of us would like to take advantage of it, and it will be surely beneficial to all of us in the future. I would also like to thank all the distinguished audience who have logged in and attended today's very interesting webinar. And I'm sure ISCC is geared up to present such more webinars in the coming future. Thank you very much, all of you.
Thank you. Thank you. Bye-bye.
Bye.
अभिजित
हा सटलो
काही रेकॉर्डिंग वगैरे केलेलं आहे ना?
या केलं
म्हणजे ते एडिट करून पाठवू